Did you know that every star you see in the night sky is bigger and brighter than our sun? It's true. These twinkling points of light are not just distant suns, they are immense balls of burning gas, light years away. Each one holds secrets about the universe's past and clues to its future. When we look up at the stars, we are looking back in time. Some of the light we see began its journey towards us millions of years ago. For centuries, humans have gazed up at the cosmos, asking questions about our place in the universe. Stars are born in vast cold clouds of gas and dust scattered throughout galaxies. These clouds, called nebulae, are some of the most beautiful and awe-inspiring sights in the universe. Within these cosmic clouds, gravity acts as a sculptor, pulling together clumps of gas and dust. As these clumps grow larger, their gravitational pull intensifies, drawing in even more material. This process of gravitational collapse generates heat, causing the core of the collapsing cloud to glow. Over millions of years, the core gets denser and hotter, eventually reaching a temperature of millions of degrees. At this critical point, a star is born. The intense heat and pressure at the core trigger nuclear fusion, the process that powers stars. Nuclear fusion is the engine that drives the life of a star. It's the process of fusing together lighter elements like hydrogen into heavier elements like helium, releasing enormous amounts of energy in the process. This energy is what makes stars shine so brightly. It's what allows them to resist the relentless inward pull of gravity. Stars like us have a life cycle. They are born, they live, and they die. The length of a star's life and the manner of its death depend largely on its mass. Smaller stars like our sun are incredibly efficient with their fuel. They can live for billions of years, slowly burning through their hydrogen reserves. Larger stars, on the other hand, are cosmic gas guzzlers. They burn through their fuel much faster, living shorter, but more dramatic lives. These massive stars blaze with incredible intensity, shining brightly for millions of years before meeting their explosive demise. As a star ages, it gradually runs out of hydrogen fuel in its core. Without the outward pressure from nuclear fusion, the core begins to contract under its own gravity. This contraction heats up the core even further, eventually triggering a new round of fusion in the outer layers of the star. The star expands dramatically, becoming a red giant or a supergiant, depending on its initial mass. The life of a star is a constant battle between gravity and nuclear fusion. Gravity tries to crush the star inward, while the energy released by fusion pushes outward. This delicate balance is maintained for millions or even billions of years. But eventually, the star's fuel runs out. As the star runs out of fuel, the outward pressure decreases and gravity takes over. The core of the star collapses, and depending on its mass, the star will meet one of several fates. Smaller stars, like our sun, will shed their outer layers into space, forming beautiful planetary nebulae. The core will remain as a dense, hot remnant called a white dwarf. Larger stars, however, meet a much more violent end. Their cores collapse so rapidly that they rebound in a cataclysmic explosion called a supernova. Supernovae are some of the most energetic events in the universe, briefly outshining entire galaxies. These explosions are not just destructive, they are also incredibly creative. The intense heat and pressure during a supernova forge heavy elements like gold, silver, and uranium. These elements are scattered into space, enriching the interstellar medium with the building blocks of planets and life. In a very real sense, we owe our existence to these stellar explosions. Section 5. Beyond our eyes, unmasking the invisible universe. The stars we see with our naked eyes are only a tiny fraction of the stars that exist. Our galaxy, the Milky Way, is estimated to contain hundreds of billions of stars, and the observable universe contains billions of galaxies. Many stars emit light in wavelengths that our eyes can't see, like infrared and ultraviolet light. Telescopes equipped with special detectors allow us to observe these hidden wavelengths, revealing a universe teeming with activity. We can study the birth cries of stars in dusty nebulae, witness the violent deaths of massive stars, and even detect the faint whispers of black holes. These invisible wavelengths also provide crucial information about the composition of stars and the environments around them. By analyzing the light from stars, astronomers can determine their temperature, chemical composition, and even their motion. This information helps us understand how stars evolve, how they interact with their surroundings, and how they contribute to the evolution of galaxies as a whole. The study of stars has also led to some of the most profound discoveries in modern physics. Section 6. When stars explode, cosmic fireworks. Supernovae, the explosive deaths of massive stars, are some of the most dramatic events in the universe. These cosmic fireworks release an unimaginable amount of energy, briefly outshining entire galaxies. But supernovae are much more than just dazzling displays of celestial light. They play a crucial role in the evolution of galaxies and the distribution of elements throughout the universe. The intense heat and pressure generated during a supernova explosion are capable of fusing elements heavier than iron, something that normal stellar fusion cannot achieve. These heavy elements, including gold, silver, and uranium, are scattered into the interstellar medium, enriching the gas and dust clouds that will eventually form new stars and planets. In fact, the very elements that make up our planet and even our own bodies were forged in the heart of a dying star billions of years ago. Supernovae also play a crucial role in triggering star formation. The shockwaves from these explosions can compress nearby clouds of gas and dust, initiating the gravitational collapse that leads to the birth of new stars. In this way, supernovae act as cosmic recyclers, scattering the building blocks of life and triggering the birth of new generations of stars. Section 7. The Mystery of Dark Matter. The study of stars has led to one of the most perplexing mysteries in modern astrophysics, the existence of dark matter. Astronomers have observed that galaxies rotate much faster than they should based on the visible matter they contain. This discrepancy suggests that there must be some invisible form of matter, dubbed dark matter, providing the extra gravity to hold these galaxies together. While we can't see dark matter directly, its gravitational influence is evident throughout the universe. It's estimated that dark matter makes up about 85% of the total mass of the universe, dwarfing the amount of ordinary matter we can see. While we don't know what dark matter is made of, its existence has profound implications for our understanding of the universe. It suggests that our current understanding of particle physics is incomplete and that there are fundamental particles out there waiting to be discovered. The search for dark matter is one of the most active areas of research in astrophysics today, and scientists are using a variety of techniques to try to unlock its secrets. Section 8. The Expanding Universe. Another groundbreaking discovery that stemmed from the study of stars is the expansion of the universe. In the 1920s, astronomer Edwin Hubble observed that distant galaxies are moving away from us, and the farther away a galaxy is, the faster it's receding. This observation led to the development of the Big Bang theory, which states that the universe began from a hot, dense state billions of years ago and has been expanding ever since. The expansion of the universe has profound implications for the fate of stars and galaxies. As the universe expands, the average density of matter decreases, which could eventually lead to a big freeze scenario where star formation ceases and the universe becomes a cold, dark place. However, other factors, such as the mysterious dark energy that seems to be accelerating the expansion of the universe, could alter this fate. Understanding the interplay between dark matter, dark energy, and the expansion of the universe is crucial for unraveling the ultimate destiny of the cosmos. The study of stars, therefore, is not just about understanding these celestial objects themselves, but also about piecing together the grand narrative of the universe, its origins, its evolution, and its ultimate fate. Section 9. Keep looking up. The next time you find yourself under a clear night sky, take a moment to appreciate the awe-inspiring beauty of the stars. These twinkling points of light are not just distant suns, they are windows into the vastness of the cosmos, each one holding secrets about the universe's past and clues to its future. As we continue to explore the universe, we are constantly reminded of the interconnectedness of everything. The atoms in our bodies were forged in the hearts of stars that lived and died billions of years ago. The very elements that make life possible were scattered throughout the cosmos by stellar explosions. We are, in a very real sense, children of the stars, and our journey of cosmic discovery is just beginning. Keep looking up, keep asking questions, and never lose your sense of wonder. The universe is full of secrets waiting to be uncovered. What are your thoughts on the mysteries of the stars? Share your comments below, and let's keep the conversation going. Don't forget to like and subscribe for more cosmic adventures.